Thanks for the intro. My name is Guohao. I'm the founder and CEO of iGenAI. And we are building an open source community called Camel AI, start from 2 years ago. It's a community building, like we are mainly working on multi-agent infrastructure, doing some research and some like framework kind of thing for developers. So today I mainly want to share some of the research and open source project we have been done in the community, and some of our thinking about the skill loss of agent. Or is there even a skill law of agents? Right. So probably you know the skill law model, but is there a skill law in another dimension? This is what we are thinking about. Probably you heard about agents many times in this conference, but I want to start from this book called The Society of Mind, which is one of the book we read a lot and we follow lots of principles from this book, and we got inspired a lot. So Society of Mind is a book by Minsky, who considers one of the founding fathers of AI. In this book, he asks lots of questions from 39 years ago. And even today, I mean, many questions are still relevant. And many people ask, like, what's agent? Probably you should check this book. So agent, like, in this book, Minsky discuss, like, how does agent work? How do they communicate? What are they made of? And so on. And the definition of agent in this book, basically here. So agents are mindless persons. Agents by themselves can only do simple things. What kind of thing is a simple thing? For example, your agent can open a door. Your agent can maybe give you maybe an apple. This kind of thing is considered as a simple thing. But if you join all those agents together into a society, this leads to the true intelligence. This is the philosophy we are following when building multi-agent framework and multi-agent system. Each agent can do simple things, but if you join all those agents together into a society, this can lead to the true intelligence. And one of the saying I really like in the book is that what's the magic trick that make us intelligent? The trick is that there's no trick. The intelligence from our vast diversity. There's not one single principle. One single perfect principle. That means multi-agent similarly, there is not just one single perfect agent. Multi-agent system, the intelligence of multi-agent system also from their diversity. The diversity can come from their diverse model, diverse tools, and diverse memory. Of course, in this book, the agent is very simple. Like you can see here. For example, if you want to build a chair detector, you can check how many conditions you got in the system. For example, if you got like 5 out of 6, then this object is a chair. It's very symbolic. It's very simple symbolic agent. But in this book, many of the concepts. This book is from 39 years ago. Many of the concepts we use today are actually very relevant to this book, but people never cite this book. For example, you must know memory. You are building long-term memory, short-term memory, and of course, like transfer reasoning. You can use transfer to improve your mathematical reasoning or common sense reasoning, and of course, agent communication or even word model. Maybe people didn't cite this book nowadays, but it's very inspiring, and there are so much more to read in this book. Of course, today we are mainly talking about language model agent. Agent, for example, one of the earliest agents is called WebGP. Agent can use browser. I just skip this because everyone knows quite well. And of course, one of the most popular agent architecture framework is proposed by Lilian. A former OpenAI researchers. She proposed this agent architecture. Agent can have tools, their memory. Agent can perform planning and action. The key difference between language model agent and multi-voice agent is that the input and output are are languages. So that means your action space, your states are so expressive. They can generalize so well. There are many related work, in these 2 years, I will just skip it, but if you are interested in the history of language model agent, probably these are the very good literature to read. So back to the main topic today about the skin law of agents. So you must know very well the skin law model. You can have more compute. You can buy just more GPU. Or you can have a larger data set by hiring more people, PhD students, to annotate your data set. Or you just have a larger model. GPTs 2, 3, 4, 5, right? They are larger and larger. But what is the skin law of multi-agent system? Like which dimension we should even look into? So the first dimension we believe is the number of agents. Not all these scenarios we need many agents, but there are some scenarios we do need many agents to be possible. So this comes to our first work called Camel. Camel is a newspaper in 23. It's the first multi-agent framework. We released this in March 23. The idea is very simple. So basically you have a role-playing system. There are two parts. The first part is the human input. The second part is the role-playing session. So human can maybe input an idea. The idea don't need to be very specific. And then you can choose two agents. For example, here you can choose AI assistant agent and AI user agent. Here we have a task called develop a trading bot for stock market. You can choose a Python programmer agent and a stock trader agent. And then there's a multi-agent system work on your task. For example, here you got an agent called task specifier that can turn your idea into a concrete plan. And then this plan will be shared by these two agents, and then they will collaborate together to accomplish the task. For example, here, the AI user agent will act as like a positive for you, and basically the AI user agent will send instruction to the AI assistant agent, and the AI assistant agent will just execute the instruction. Let's say, here you can see the AI assistant agent can install the library, can import the library, and build the whole system together by multi-localization. And here is a demo I built like 2 years ago. These two agents collaborate with each other on building a game. You can see here. They talk to each other, and then you can run the code, and you can see a game demo like this. So the first question we want to ask is, so is like more agent actually better than one? Otherwise, why we need multi-agent system, right? So in our evaluation, we do like more than 200 tasks, and we use both human and GPT-4 as an evaluator to see if the multi-agent system perform better than one single GPT 3.5, and more than 17% of the time, they are actually better. Of course, back then, there are not many benchmarks, and we try very hard to figure out how to benchmark it. But today, the benchmark is still missing parts in multi-agent system. So how, I talk about agent, I talk about Camel. Camel is a multi-agent framework. How can you build an agent in Camel? It's very simple. So basically, there's a cornerstone called chat agent. If you want to build a chat agent, in Camel, you need to specify mainly 4 things. The first thing is the system message, and the second is the memory of the agent, and then the tools, and then you can interact with the agent with a step loop. In the step loop, your agent will tell us input the message, and you can also specify the response format for the agent, and the agent will just do the context management automatically, and then send a request to the model. If it's a function call, then execute function call. If not, then respond to the user with the specified format. So Camel, I just talked about Camel, like you can use 2, 3 agents to build like a game or some kind of like automation. But what can we further do if we, for example, if we have millions of agents, or what kind of scenario is meaningful for agent system with millions of agents? So this is our second open source project called Oasis. In this project, we try to use million agents to replicate, let's say, the social science phenomenon in the human society. And of course, you can also use it to explore the dynamic of agent society in the future. For example, you can use it to simulate herd effect. Humans have herd effect. If we go to the restaurant together, maybe I order something, you order the same. Does agent also have the same phenomenon? We build a sandbox like Reddit. You know Reddit very well. You can post in Reddit, and you can try to use our sandbox to simulate how agent react to these like posts. For example, you send a post called Earth is flat, and you initiate this post with different conditions. For example, like or dislike, and you can see how agents react to this. And very interestingly, we find agents are more likely to have a herd effect than human. This probably is because of the alignment problem, maybe. They are too aligned to human preference. You can also use it for simulate information propagation. The Oasis is an infrastructure for simulation, basically, for multi-agent simulation. You can easily create any sandbox for different simulation. Here, we create a sandbox called X, just like Twitter. You can script the data from the X user and their posts, and then you use that as the agent persona, and then, of course, their relation. And then you can simulate how Twitter propagate in this sandbox. Right. So we measure a couple of dimensions, how many people, basically the skill, how many people see your tweet. The second dimension is the depth, how many hops your message propagate in the simulated sandbox. And the third dimension is the breadth, basically how many first neighbor people see your tweet. And we find that they can simulate to some fidelity, but there's still a huge gap between the depths. This is also an open problem to be solved, because a human does not only interact in the sandbox, we interact in the physical world as well. So for example, I come here today, maybe we know each other, maybe we follow each other on X, and then maybe I post something, and this can be, this message will propagate much further than only in the sandbox. Right. This is very difficult to simulate still. You can also use it for rumor simulation. We know misinformation propagate much faster than the truth in human society. Does this happen similarly in the simulated sandbox? You can see here we do some experiment and we find like a similar trend in the simulated sandbox. So Oasis as an infrastructure, as a framework for building agent simulation, you can easily specify any action and any sandbox you want. For example, here, you can choose the action space. I just mentioned you can create act sandbox. What kind of action you have? You can have like create posts, like posts, repost, or follow others, or maybe unfollow others. Right? You can choose any action you want to build different sandbox. If you maybe you're not interested in X or not interested in Reddit, maybe you're interested in, I don't know, Weibo or Instagram or something, you can choose just different action to build your simulation. And then you can, of course, like reset your environments and then do environment step to interact with your agent. And if you know, if you are working on maybe reinforcement learning related research topic, you will see this interface be very similar to the OpenAI Gym. Yeah, so this is the first dimension, the number of agents. With 2-3 agents, you can build like a game, you can maybe use them to automate your tasks in your browser. With millions of agents, you can simulate maybe some fidelity of human society like interaction, right? So this is the first dimension we think is very important. And the second dimension we believe is the environment. So language models have their data from the internet, but the data for agent is different. The data for agent is the environment they live in, they operating in, and so how can we build? Can we build more environment for agents and let agents to learn in the environment to achieve this scaling better? This is the second dimension we are looking into, how to build more environment for agents and how to generate tasks from the environment and how to specify maybe verifiable reward in the environment. So this came to our third community open source project. It's also a research project with our open source community called Crab. Crab is an agent that you can operate mobile, operate your desktop. We build samples in Ubuntu system and Android system, and we enable automatically generate tasks and Sybin automatically generate the evaluator for the task. So basically, it's a cross environment task benchmark system. So you can have you have tasks on your mobile on your laptop, and we support automatically task generation and fine-grained evaluation of your agent. The evaluation of agent is also a very difficult problem. So in language model, we evaluate the language model by just 0 or 1. But for agents, many agents, their tasks are very long, multiple steps. How can you better evaluate that? We propose a way called graph evaluator in our framework, and this can give you more fine-grained reward of your agents. And of course, it's multimodality because your agent will see the screenshot of the system and the instruction as well. So here is an example like what kind of tasks you can do or evaluate or train your agent. Here is a demo task. You can open Slack, navigate to the multimodality benchmark channel, summarize the message, and then send the message to your contacts on your phone. Right. You can see the task is the task cross 2 environments in your desktop and mobile. So basically, to build an environment like that, what component you need? So first of all, is the action space. Just like Oasis, you need to specify the action for your agent. And secondly, the evaluator. How do you evaluate your agents? And then the environment. It can be desktop environment. It can be a mobile environment. The task, which task to evaluate, and the benchmark as well. So in this project, we propose a way to automatically generate tasks. It's quite researchy. So I will just mention. So basically, it's a graph, a heterogeneous graph of your subtask, and then you sample a subgraph from this task, and then you can generate tasks from this subgraph. And of course, you can also evaluate this task more fine-grained because you have the graph structure of your task. You can just check how many nodes your agent complete in this task. For example, if your agent complete 1 node, should be different from the agent complete maybe 5 nodes in your task. Right? That enable more fine-grained evaluation of your agents. And we recently released a project called OWL. This OWL project we got about maybe 12K GitHub star in maybe about a week after the release. So you can consider it's an open source version of Miners. I know I guess yesterday or this morning there's an open Miners talk as well. So really something like in the same day. So the R project is a project, it's an agent that you can use for browser automation, doing search. You can also generate code, SQ code, and also like process your document. So basically, it's like Manus. And of course, more than that, you can plug in any MCP server you want to this agent system. So this is a project that we support like many. You can use any open source model or any API provider with it. You can also use any search tool you want. Maybe you like Google search, maybe Baidu. And you can also process like multimodality document like image, video, audio with it. And of course, browser automation is one of the key parts of it. We use Paywire to automate your browser. And then document processing, code execution, and MCP protocol is supported. So that means you can use any tools you want from the community. Here is a demo what you can do with the R project. Yeah, I guess here the task is to ask the agent to do a research about the Camel framework GitHub and maybe plot the statistic of the GitHub. So you can see the agent, we open the browser. It's a little bit slow. The agent opened the browser, use the browser toolkit, and then maybe, yeah, we just check like how many GitHub stars and folk are there, and then it generates a Python script to visualize it, like here, and then it actually runs the code for the task. And here is the code generated. Of course, you can do more complicated tasks with this. Here is one demo that you can automate tasks in your browser. The second demo is you can connect it with whatever MCP servers you want. Here we show a demo. You connect with a WhatsApp MCP with your R agent. Then, so the agent can reply a WhatsApp message for you. So you see here, we receive a message from the sender. The instruction is to ask the agent to read the message and reply to it. So the agent uses DataGo to search the relevant information and then reply to the message, basically. Yeah. Okay. Yeah, another demo, you can also automate tasks in your, I guess, Notion, this one. So you can connect your Notion with there's Notion MCP out there. You can very easily connect it by just a config file. And then, for example, here we can ask the agent to generate a travel plan in your Notion, very simple demo. You just need to set up the authentication, and then you can run it. I promise we will make a better UI later on, but now it's all in the VS Code. Yeah, a demo like that. So yeah, this is the GitHub star we released after a week. Yeah, many contributor projects. I'm very grateful for that. And this is not, a simple application. It's actually research which we have been done for a while. And we achieved the top one performance on the Gaia benchmark, which considered as one of the most standard benchmark for journal agent. Recently we also updated the model from GPT-4o to Cloud 3.7, and there's a 10% improvement. That's quite amazing. The trick to achieve the best performance, they are not magic. It just optimize the toolkits and prompts and things like that. But we are also working on doing reinforcement learning to improve the open source model to be on par of the closed source model. We are training the QN model with reinforcement learning, multi-agent reinforcement learning actually at the moment. Yeah, this is the second dimension to scale up. So if you can build many environments for your agent, like browser, like terminal, like maybe desktop, maybe mobile, and so on, this is a way for your agent to interact and do reinforcement learning, maybe collect data, and so on. And we believe this is very important for scaling up the agent. After the environment, I think it's the ability of evolution. Only if the environment is not enough, your agent still need to learn or evolve in the environment, right? So this is the third dimension. But what's the difference between like evolution of agents and training of model, right? I think the evolution of agents should be, can be more agentic. Your agent don't need to like just rely on human annotation. Your agent can generate their own data, can provide reward for themselves, or even doing reinforcement learning. So we have been working on like this direction quite a few. We collaborate with Mistral. Of course, everyone knows Mistral here. So we do this called Graph IAG. Basically, agent automatically generate knowledge graph for themselves. And then you can use the knowledge graph combined with your unstructured document to generate your answer, right? This is a way. Like human does not, when human interacts with the physical work, human generate like concept, right? Concept is like knowledge graph. So agents should be the same. They should be able to generate knowledge graph in their memory for their task. And the second direction could be interesting is agented data generation. You must know data generation. But what's agented data generation? If you give a task to an agent, can your agent just go to the internet, script data, and then generate training data from themselves? And then they can train on the data and deploy the model automatically to improve. So we build this pipeline. Basically, agent can use like some web scripter, go to the internet, script relevant data for your task, generate SFD data, fine-tune it with onslaughts, and deploy the model. And also verifiable sensitive data. Data generation is easy, but generate verifiable sensitive data is very difficult. How can we enable that? We recently have a project with our open source community called LONG. We have more than about 50 researchers contribute to the research project. So in this project, the idea is simple. We first collect some seed data set with the community together. And this seed data set will be used for generating data in the environment part. So there is a generator. The generator will generate synthetic question and synthetic answer from the seed data set. And there's a verifier. We use the agent to verify the generated answer. So what kind of answer you can, what kind of verifier you can use? For example, symbolic math. Right? There are many questions about symbolic math. You can use SymPy as a verifier. Right? And maybe graph. So for problem in graph, you can use computational library like network X as a verifier to generate the code and try to solve the problem. And many other questions. For example, mathematical programming, you can use like Groovy, discard solver to solve the task. And also logic, you can use Prolog for that. So the idea is that we generate synthetic questions, synthetic answer. We use agent to verify the synthetic answer by calling like human crafted library and toolkit. And then we check if the generate synthetic answer align with the COT answer. If they align, then this is a consistency reward. And the chance of both of them are wrong and align is very low, so that you can use it for train your agents. This is basically a framework for generate many synthetic verifiable data for various domains. Okay, so we are also working on reinforcement learning, but we haven't released things yet, so we'll talk about this later. But basically, this is what we think could be the next scale law. To scale up multi-agent system, you need to be able to build very large multi-agent system, maybe with millions of agents. And Camel is the framework to enable that. And the environment is the data for agent. We need to build more environments. The current environment is not enough. There are maybe like environment for simulation, the environment for automation, environment for data generation, and much more than that. And the training part is the evolution of agents. You can build knowledge graph, you can build automatically data generation pipeline, you can do verifiable synthetic data generation, and you can do reinforcement learning with for your multi-agent system. Okay. Yeah. Last but not least, I want to introduce Voice Camel. Camel is the first multi-agent framework. Maybe many people heard about AutoGen, but we are much earlier. Like 6 months, we are continuously building that. We didn't split into two. So yeah, we are a very well-maintained multi-agent framework in the community, and many researchers and contributors contributed to our framework. So it's a go-to framework if you want to build data-driven agents, not just prompting, but if you want to generate data and train your agent, maybe that's a framework to go into. Here is some of the open source project I mentioned. The Camel, the R project, and the Oasis, and Crab, and Long, and yeah. Of course, all those contributions is not done by me. It's for the whole community. We have more than like 200 contributors in our GitHub. Yeah, I would like to thank everyone for the contribution. And of course, if you are interested in joining the initiative of finding the skill of agents, you're welcome to join us as well. Yeah, that's my talk. Thank you, everyone.